Today we're going to start a new topic in geometry. We're going to start talking about perpendicular lines. Now we already know there are quite a few special types of lines that we've learned about. The first type are parallel lines, which are, kind of like those little train tracks going down the line there. They never intersect with each other. And if our two lines were named M and N, we could say that M is parallel to N, and this right here would be the notation that we use to indicate parallel. The next type of line that we are familiar with are intersecting lines. That is, these are lines that eventually cross each other. And to notate that, we would say simply that M is not parallel to N. Today we're introducing perpendicular lines. Perpendicular lines come together like this, and our notation is that M is perpendicular to N. So this little symbol right here means perpendicular. Now you're probably saying to yourself, great, I've seen the picture and I understand perpendicular lines, but I know she's going to make me have an official definition. And you're right. So let's draw some lines and let's talk about what it means for two lines to be perpendicular. Well, what it really means is that when they come together, they form right angles, angles that are exactly 90 degrees. In fact, all of the angles that are formed when two perpendicular lines come together are exactly right angles. So the definition that you can write down is that two lines are perpendicular if and only if they form right angles. Now let's explore this concept of perpendicular lines a little more comprehensively. So let's say that we have line L going across and we have a transversal line M cutting it. And we also happen to know that when M cuts line L, it forms a right angle, a 90-degree angle. And then let's say that we have another transversal. We're going to call it line N. And when that transversal cuts through line L, it also forms a right angle. So what, you say? Well, the so what is that now we know with absolute certainty that line M is in fact parallel to line N. Wait a minute, you might be thinking. How is it exactly that we know that? Well, it might help if we flip the diagram on its side. So let's draw our M and N, this time as horizontal lines, and we'll make our transversal, the blue L line, vertical. And then I will also take the time to match up the right angles that have already been indicated. Now these right angles are something special. Perhaps you recognize them for what they are. That is, they are corresponding angles. And whenever we see corresponding angles, especially corresponding angles that are equal to each other, we get all excited because we can now use the CAP theorem from last chapter. CAP, remember, means that if you have corresponding congruent angles, then you know that that implies parallel lines. Here we have two 90-degree angles. The two 90-degree angles are obviously congruent, which means that line M must indeed be parallel with line N. Here's the theorem that you can write down. If you have two lines that are perpendicular to the same line, then they are parallel to each other. It's always nice to have a new theorem in the books. Let's do one more just for fun, shall we? Okay, so in our next slide, we now have two lines. We have line J and we have line K. And we're going to say that we know that these lines are parallel to each other. That's part of our given. So now we draw a transversal. And in this case, we have a transversal T. We know that our transversal T is perpendicular to line J. We know that because it formed a 90-degree angle. Well, What can we say now? Well, we can say that line T must also be perpendicular to line K. How do we know this? Look, there are two corresponding angles. Both of those angles are above the blue lines and to the right of the yellow line. And we have a special rule that applies to corresponding angles. We have the PCA. That says that if you have two parallel lines cut by a transversal, the corresponding angles must be congruent. In other words, parallel lines imply congruent corresponding angles. I just love that. Okay, let's write down another theorem. It says if a line is perpendicular to one of two parallel lines, then it must be perpendicular to the other. Okay, now it's time to stop and take inventory of what we've learned. First of all, you should have your definition of perpendicular lines in your notes. And you should have the two new theorems that we've discussed. The first one says that if two lines are perpendicular to the same line, then they are parallel to each other. And the second one says if you have two parallel lines and a transversal, if your transversal is perpendicular to one of them, then it is also perpendicular to the other. Please put these theorems and this definition in your notes right now. We're going to be doing some more theorems in our next video, and you will certainly need these.